Kruskals algorithm. Before we get into that, let's remember what minimum spanning trees are. Minimum spanning trees are subgraphs of a given graph that connect all the vertices, but they contain no cycles. And the reason we call them minimum spanning trees is the edges we add in that graph, when we add their edge weights, that's the minimum we can get. Now let's go to Kruskals algorithm. Kruskals algorithm is an algorithm that creates a minimum spanning tree from a given graph. So this is an example graph that we have, and let's run Kruskals algorithm on it. Kruskals algorithm runs on basic principles. So we pick the edge with the smallest edge weight and we add it to our graph. And we look at these edge weights, we see that the edge weight with 1 here are the edge weights with the smallest. So let's add the first one. And we connect B to D. And let's show it in our subgraph here that we connect B to D. Now we check the next edge with the smallest weight, and as we can see, it's 1 here. So we add this one to the graph too. And C to F, we connect the vertices like this. And now we're going to check the edge with the next smallest weight. And when we look at all the edge weights, we have 2 here and another 2 here. It doesn't matter which one we add first, so I'm going to go ahead and add this one. Yep. And we connect B to E. And then next, we're going to add the other 2, which connects A to D. Perfect. Now we can see our subgraph. Most of the vertices are connected, but there's only one left, which is G. Now, in the graph, we're going to look at the edge with the smallest weight that we can include. There's a 3 here. Why don't we go ahead and add it? But if we add that one here, we can see that we have a cycle between B, D, and E. And what we said was, in a minimum spanning tree, we cannot contain a cycle. So that edge is not an edge that we can choose from. So let's cross that out. What is the next edge with the smallest weight? We check the edges and we see a 4 here and another 4 here. Let's see if we can add this one. If you add this 4 to the graph, we see that we create another cycle between A, B, and D. So that's not an edge that we can choose. And we're going to check the next edge, which is the other 4, and see if we add it, if there's going to be any cycles. And no, there's not going to be any cycles. So let's go ahead and add that one to our graph. And now we have this edge. So we added those edges and we're going to check the edge with the next smallest weight. We have a 5 here. Let's see if we can add that one. If we add the 5 here, we're going to have a cycle between A, D, F, and C. And that's why we cannot add that. Let's cross that out. Also, we crossed 4 out too. And what is the next smallest edge with the smallest weight? We see we have 6, 7, and 10. And obviously 6 is the smallest among them. And we connect F to G. And let's show it in our subgraph here. And now we can see that we connected all the vertices and we contain no cycles. So this is a minimum spanning tree. And let's put the edge weights here. This is 1, this is 2, there's 2, there's 1, there's a 6 here, and there's a 4 here. And if you want to find the weight of this graph, the weight is equal to adding all the edge weights. So we have 2, we have 1, 3, 5, 9, 10, 16. So the edge weight of this minimum spanning tree is 16. Thank you.